Precious learners, welcome to Black Slides Online Secondary School. This is the place where you learn the sciences, namely physics, chemistry, biology, agriculture, and the mathematics. You are welcome back after a short break which resulted from our technical challenges, but now we are glad to inform you that we are back on a full swing. We regret any inconveniences that we might cause during the break. Our commitment to teaching you still remains intact, and we are going to ensure that learning accelerates as much as possible to cover what we might miss during the break. Remember, we are running holiday lessons up to the end of this holiday, long holiday. Welcome once again. If you are in Form 3, these lessons are meant for you. If you are writing your MSc in 2027, you are welcome to the platform. It is going to be of help if you subscribe to this channel if you are watching on our YouTube channel. Also, remember to hit the notification bell. Doing so will help you to be notified every time we upload a new material from this end. Welcome, learners. So we meet now for a lesson on Form 3 Agriculture on a topic called Chemical Properties of Soil. This happens to be lesson number 2 since we opened our online holiday lessons. Remember, the first topic we looked at the physical properties of soil. Now we progress to the next component of properties of soil, which is the chemical properties of soil. Chemical properties are those properties of soil which determine the chemical reactions or the chemical composition of soil. Let me point out that this is going to be a long video lesson because we are going to cover the whole component of chemical properties of soil. All right, it's going to be a long topic, rather a long video. You may consider to break this into manageable chunks by watching the first 40 minutes and then you break and you progress to the next 40 minutes and like that until you finish the video. I wouldn't really recommend that you skip the components of the lesson, because in so doing you're going to miss out the key aspects of the chemical properties of soil. So in the lesson we are going to look at the soil pH, nutrient content, cation exchange capacity, also known as CAC, and then lastly we'll discuss soil salinity. So we are going to look at each one of them in detail and how each affects agricultural production. This is Black Slides Online Secondary School. In case what you want is to join our main classroom, don't hesitate to send us a text message to the number shared here, we are going to come back with the details regarding the joining process. Welcome learners, invite your friends wherever they may be so that they can as well join us as we cover topics in Form 3 Sciences as well as Form 4 Sciences. So invite your friends. If you are watching on our YouTube channel, consider subscribing to the channel. Remembering to hit the notification bell. This will help you to be notified every time we upload new material. Welcome learners. So without wasting your precious time, let's get down to the business of the day. This is Black Slides Online Secondary School. So apart from the physical properties or the physical aspect of soil, soil has also chemical properties that need to be understood in order to improve crop production. So this includes soil pH, nutrient status of the soil, which is also called nutrient content of soil, ion exchange capacity, and the soil salinity. So like I said, in this lesson we are going to explore each one of these chemical properties. Pay attention to the definitions, the descriptions, and how each one of them contributes or affects agricultural production. As we go along, I'll be giving tips on examinations, the potential examination questions from each one of these properties. So pay attention to such tips because they are the ones that will help you prepare fully for your MSCE exams. Remember, it is only Black Slides Online platform where we teach the sciences honestly and earnestly. We also try our level best to cover the syllabus as it is in its undiluted form to ensure that our candidates are fully and effectively prepared for the exams. Welcome learners. So this lesson is about chemical properties of soil, such as soil pH, nutrient status of the soil, which is also called the nutrient content, cation exchange capacity, and the salinity. Welcome learners. Let's begin with soil pH. Written like this, P has to be small p and the H capitalized. I've always mentioned that in order to unlock the understanding of any topic, it is important to give the definition of the topic from the point where the topic appears. So what is soil pH? Let's define soil pH. What do you think pH means? Of course, I've heard people trying to define pH as potential of hydrogen or power of hydrogen. Much as that makes sense, as if you are trying to say pH in full. It doesn't represent the real definition of pH. So I'll discourage you from saying so pH is power or potential of hydrogen. The word or the term potential doesn't really make sense as to the definition of the real definition of pH. So we shall define pH. Just appreciate the definitions of pH, what pH is in its true sense, and not as potential or power of hydrogen. Because pH is not only to do with hydrogen, it has to do with other ions too, such as hydroxide ions. So I shall try as much as possible to desist from defining pH as simply power of hydrogen or potential of hydrogen, as some people try to define it. Right, so pH, as we are going to use the term in this lesson, pH is just the degree of acidity or alkalinity of the soil. So soil pH is the degree of acidity or alkalinity of the soil. How acidic or alkaline a soil is called soil pH. So this is the definition I would love you to embrace. As we discuss soil pH, it is the degree of acidity or alkalinity of the soil sample. If we are to get deeper into chemistry, we shall define pH as the negative logarithm of the hydrogen concentration. So if you take the concentration of hydrogen ions and then negate it, take the logarithm of that. This logarithm is the mathematical logarithm. So the negative logarithm of the concentration of hydrogen ions is called pH. So given the concentration of hydrogen ions in the soil or in any other solution, the negative logarithm of that concentration is going to give you pH. Remember, concentration is simply refers to the number of moles of a solute. In this case, we are looking at hydrogen ions per unit volume of the solution. Number of moles. So the amount of hydrogen ions per unit volume of the, in this case, could be a soil solution or a solution made from soil. Because by that, we are not implying that soil is soluble in water. No, but if you would get a solution managed to get a suspension from a soil sample and then determine the concentration of the hydrogen ions in it, then negate it, get the negative log of that concentration, it will give you pH. But for now, we'll take it simply as simply the degree of acidity or alkalinity of the soil, pH. Soil pH is simply the degree of acidity or alkalinity of the soil. Is how acidic or alkaline or basic the soil is. That's called the soil pH. So mathematically speaking, therefore, pH of the soil sample is the negative of the logarithm of the concentration of hydrogen ions. Alright, so this is how we are defining soil pH. It's the degree of acidity or alkalinity of the soil sample. It is also the negative logarithm of the hydrogen concentration, expressed mathematically like this. Welcome to Black Slides, learners. Invite your friends wherever they are so that you can also join us. They can join us on this platform and learn during this holiday time. Make the best use of this holiday time by learning with us. In case you'd like to enroll for the holiday lessons, don't hesitate. Just send us a text message on the number shared here. We are going to come back with the joining details. Welcome, learners. So, when we are describing soil pH, there are two types of ions that determine soil pH. Two types of ions are responsible for soil pH. So the ions that determine soil pH are hydrogen ions, written as H with a super plus. So the concentration of hydrogen ions in a soil sample determines soil pH. But also what we call hydroxide ions, or H super minus. That's why I tried as much as possible to get away from the temptation of defining pH as power of hydrogen alone. You see here, so pH is not just about hydrogen ions, it's about hydrogen ions and hydroxide ions. It is the hydrogen ions that determine the acidity of a soil, and it is the hydroxide ions that determine the alkalinity of the soil sample. The more the hydrogen ions in a solution, the more acidic that solution is, or that soil sample is. And the more the hydroxide ions there are in a soil sample, the more alkaline or basic that solution is. So these two ions decide the soil pH. Let's look at some conditions relating to soil pH. In a given soil sample, the number of hydrogen ions can be equal to the number of hydroxide ions. If there is a soil like that, then such a soil is considered to be neutral. In terms of pH, such a soil has a pH of 7. A neutral solution has a pH of 7. So it exists when the number of hydrogen ions is equal to the number of hydroxide ions. Let's say you get a soil sample and then you test for its alkalinity or basicity by measuring the exact number of hydrogen ions and the hydroxide ions. If the two are equal, then such a soil sample is neutral. But if in a given soil sample the number of hydrogen ions is greater than the number of hydroxide ions, then such a soil is considered to be acidic. A soil is acidic if the number of hydrogen ions is greater than the number of hydroxide ions. In such a soil sample, in terms of pH, the pH is lower than 7. Remember that the lower the pH of a solution, the more acidic that solution is. On the other hand, when the number of hydroxide ions is greater than the number of hydrogen ions, such a soil is considered to be alkaline or basic. a basic solution or alkaline solution, in this case soil sample, has a pH greater than 7. Remember that the bigger the pH of a solution, the more alkaline that solution is. So a soil sample that has a pH greater than 7 is highly alkaline, or basic. Welcome learners. This is Black Slides Online Secondary School, where you learn the sciences. And we are meeting now to discuss chemical properties of soil. So far we have defined the meaning of pH, we have defined pH, soil pH, and we've looked at the ions that are responsible for alkalinity or basicity of a soil sample. When the number of hydrogen ions is greater than the number of hydroxide ions in a soil, then such a soil is considered to be neutral. The neutrality is coming in because the number of positive charges is going to balance the number of negative charges present in the soil sample, making the soil neither acidic nor alkaline. When the number of hydrogen ions is greater than the number of hydroxide ions, such a soil is considered to be acidic. It also follows that when the number of hydroxide ions is less than the number of hydrogen ions, then the soil sample is acidic. And when the number of hydroxide ions is greater than the number of hydrogen ions, then such a soil is considered to be alkaline, having a pH greater than 7. As a science student, you'll be required to either demonstrate, you'll be required to measure this pH of a soil sample, or in a paper 2, you may be required to describe how you can measure the pH of a soil sample. So we are going to discuss the methods of testing soil pH. Let's look at the methods of testing soil pH. The alkalinity or basicity, or acidity or alkalinity of a soil sample. How can you test if a soil is acidic or alkaline? Two methods are going to be discussed. Soil pH can be determined by using any of the two methods, namely by using what is called a universal indicator solution. We shall see how this can be done. You can also use litmus paper. Of course, a more reliable way to find this pH of a soil sample is to use universal indicator solution, because universal indicator solution can give you the exact pH. Litmus paper doesn't give you the exact pH, the strength of acidity or alkalinity of the soil sample. Litmus paper can only tell you if a soil is acidic or alkaline. It will end there, but it will not give you the exact pH value. So the universal indicator can go as far as telling you that the soil sample is acidic or alkaline. Apart from that, it will also indicate, it will tell you the pH value. Another method is to use what is called the pH meter, which we have not discussed in this lesson. Alright, so we are going to discuss these two methods of testing soil's acidity or pH, soil pH. So let's look at how we can determine soil pH using universal indicator solution. So we shall start with that method. So in order to test a soil for pH, you outline the following, you do the following. This is a potential examination question. Describe how you can test the pH of a soil sample using universal indicator solution. This is the method that I would like to take you through. So pay attention. And this is how you are going to write in your exams if you are asked to describe the method of determining the pH of a soil using universal indicator solution. So put a soil sample in a test tube to a depth about 1 centimeter. That's what you do first of all. So get a soil sample in a test tube to a depth of 1 centimeter. Alright, then add an equivalent amount of barium sulfate powder to the test tube that contains the soil sample. The use of the barium sulfate is to flocculate and precipitate this clay, or to break down the soil particles further. That's the use of barium sulfate. So the soil particles will be broken down by the action of barium sulfate. You may be asked to say why you have to add the barium sulfate to the soil. It's in order to flocculate and precipitate it, meaning to break it down further into soil particles. So break down the soil particles further. Then you add distilled water to soil sample. It is important to add distilled water because distilled water does not contain any dissolved substances. Therefore, it will not affect the pH of the soil which you are testing. So it's advisable to use distilled water in this experiment. Remember, distilled water is free from dissolved substances. Otherwise, if you use ordinary water from the tap, ordinary water from the tap has some substances dissolved in it, and that may affect the results of the experiment if used. Then shake the test tube strongly or vigorously. Shake the test tube. At this point, the test tube contains soil sample and the barium sulfate. So shake the mixture as well as water. Mix the water, the barium sulfate, and the soil properly. Shake vigorously. Alright. Allow the contents of the soil to settle down. Then add 8 to 10 drops of the universal indicator solution. Remember, universal indicator solution will tell you two things: whether the soil is acidic or as well as the exact value of the soil pH. Right. Then shake the test tube as well to allow the contents to settle for about 30 to 60 minutes. This is roughly half to an hour, half hour to 1 hour time. Then hold the test tube against the printed color chart, which is called the pH chart. The aim is to compare the color you see in the test tube and that one printed on the chart. The chart has the pH chart has colors, and each color represents a particular pH value. Alright, then you compare each color on the chart with the color of the suspension and note the pH of the color which matches it most closely. Right? So if the color of the suspension is pink or red, then the soil is acidic. So by just matching, observing the color of the suspension of the soil, matching it with the color on the chart, it will tell you whether the soil is acidic or not. So if the color of the suspension is pink or red, then the soil is acidic. So an acidic soil will give a pink or red color of the soil suspension. If it is blue or purple, then it shows that the soil is alkaline. Or if it is green, then it is neutral. So this is what you should do in this experiment. Welcome, learners. So this is how you will present it in an exam, in paper 2 especially. Question 1, in the question 1 or 2. Or if it's the other way around, maybe 3 or 4. Make sure you know how to write properly like this to describe the experiment, how you can test a soil sample for pH to determine whether it's acidic or not acidic. So there are 10 points. That means each point is 1 mark to give you a total of 10 marks. Welcome, learners. Using a litmus paper, remember that litmus paper can only tell you that whether the soil is acidic or alkaline, but it cannot give you the pH number or value. That's one weakness of litmus paper. So you put some soil solution on a white tile. If you want, you can put in a test tube. Alright. Then dip a litmus paper into the solution and observe color change. If the blue litmus paper turns red, then the soil is acidic. So an acidic soil will turn blue litmus paper red. That tells you that the soil is acidic. But if the red litmus paper, take note, we are switching between using blue litmus paper and red litmus paper. So first you dip whichever you start with, it's okay, the order doesn't matter. So if the blue litmus paper is the one you start with and you observe that it turns red, then the soil is acidic. But if the red litmus paper turns blue, just the opposite, does the opposite, then the soil is basic. So a basic soil sample will turn red litmus paper blue, while acidic soil sample will turn blue litmus paper red. That's using litmus paper. Welcome, learners, to Black Slides Online Secondary School, your school. What are the factors that determine the soil pH? Whether the soil has to be acidic or basic, what are the factors that affect the soil pH? One of the factors that affect soil pH is a process called leaching. Leaching is the washing away of the minerals in the soil. So when mineral salts are washed away, the pH of the soil will decrease. So leaching is one of the factors affecting soil pH. It decreases soil pH. This is done by when hydrogen ions replace calcium ions, sodium ions, and magnesium ions, and these are washed down the profile, making the soil pH lower. And you know what that means? It means that the soil becomes acidic. So, lower pH values means high acidity. A soil that has a lower pH is more acidic than the one that has a bigger pH. Remember, pH values and the acidity vary inversely. The lower the pH values, the higher the acidity, or the greater would be the concentration of hydrogen ions. So leaching is one factor. It decreases soil pH, meaning that it makes the soil more acidic. The hydrogen ions replace calcium. Calcium ions, sodium ions, and magnesium ions. These are washed down the profile, making the soil have higher concentration of hydrogen ions and therefore making it highly acidic with lower pH. Another factor is the use of acid-forming fertilizers. So when you use fertilizers that form acids in the soil will become more acidic. For example, the application of sulfate of ammonia. Alright, so continuous and heavy application of sulfate of ammonia makes soil acidic, meaning it reduces soil pH. So adding sulfate of ammonia will form an acid called this sulfuric acid. Sulfuric acid will make the soil highly acidic, but it will reduce the pH. So pH decreases, but acidity increases. In other words, what the sulfate of ammonia will do is to add large amounts of hydrogen ions to the soil, reducing the pH and increasing the acidity. Another factor that determines soil pH is microbial activity, the activity of microorganisms such as bacteria, fungus, and others found in the soil. So the activity of microorganisms would decrease soil pH through the release of hydrogen ions during the decomposition of organic matter. Remember that when microorganisms decompose organic matter, which is dead plant and animal material, they release carbon dioxide. The carbon dioxide will dissolve in water found in the soil to form carbonic acid, which will add the hydrogen ions to the soil, making it more acidic and a lower pH. You must understand very well that when pH decreases, acidity increases. So we are saying microorganisms in the soil, such as bacteria and others, will produce carbon dioxide, and that carbon dioxide, once dissolved in water, it will form carbonic acid, which will make the soil hardy, the soil highly acidic with lower pH. Lower pH means high concentration of hydrogen ions. Another factor that affects soil pH is weathering of parent material. The rock from which the soil is made will determine the acidity of the soil. Some parent rock or material from which a soil is made during weathering contains sulfur. Sulfur, once dissolved in water, will form sulfuric acid. This will lower pH but increase the acidity of the soil. So the parent material that contains sulfur will decrease soil pH through formation of sulfuric acid. So the sulfuric acid will make the soil highly acidic, and this will result into decrease in soil pH. So soils formed from limestone, we are still looking at weathering of parent material. Soils formed from limestone. Remember, limestone is a calcium carbonate, which is a base. So soils formed from limestone have a high pH. So if the soil contains calcium hydroxide, which is limestone, once dissolved in water, in such a soil will become highly alkaline, and so the pH would be greater. So the higher the pH, the greater the alkalinity. We are discussing the factors that affect soil pH. So parent material that results in the accumulation of such ions as potassium, sodium, calcium, and magnesium will increase soil pH, making it more basic. I would encourage you to know how each of the factors changes the pH of a soil, because that's where the examiners will have to dwell when examining you on the factors that affect or influence soil pH. So use of acid forming, fertilizers, microbial activities, weathering of parent rock, and others. For each of these, make sure you know how pH is affected. Another factor affecting soil pH is nutrients uptake by plants. That's absorption of nutrients by plants. So some nutrients get lost during harvesting, and these are replaced by hydrogen, which increases soil acidity. And in the process, pH decreases. Remember that when pH decreases, acidity increases. A soil which has lost or which has more hydrogen ions is more highly acidic than one which does not have a lot of hydrogen ions. Another factor affecting soil pH is type of vegetation in the soil. Some vegetation produce a lot of organic matter, releasing nutrients that influence soil pH. Right? So amount of soil covered by the vegetation influences soil pH. Soils in forests, for example, tend to have a lower pH than those in grassland. Last but not least, soil pH is affected by poor drainage. Sandy soils have lower pH as it is prone to leaching because the elements, the ions, the metal cations in it are lost by leaching. So those are replaced by hydrogen ions, which lowers the pH, soil pH. How do we maintain or improve or modify soil pH? This is an examination question. How do you make a soil better for crop production? Remember that different crops prefer different soil pH. So ways of maintaining or improving or modifying soil pH, you'll be asked in an exam, describe any 3 ways of maintaining soil pH. So one way is to apply lime. It's called the process called liming. Liming is the application of agricultural lime. It is calcium hydroxide. So if the soil is acidic, upon adding lime to it, the lime is going to neutralize the soil acidity. This is a neutralization reaction which you learn about in chemistry. Since lime is a base or an alkaline, it's going to neutralize the acid. In the process, it will increase the soil pH. If all you want is to increase the soil pH, then you can do that by simply adding lime. The process by which this is done is called liming. You can also modify soil pH by application of inorganic fertilizers to increase soil pH. So a good example is application of acid forming calcium ammonium nitrates. So if all you want is to raise the soil pH, you can apply acid forming calcium ammonium nitrates. You can also do so by applying organic matter, which is manure. This will reduce acidity in the soil through released calcium ions and magnesium ions. So know all the 3 methods of maintaining or modifying soil pH so that you can answer any 2, you can give any 2 when required in an exam. How does soil pH affect agricultural production? This again is a potential examination question. Explain any 3 ways by which soil pH affects agricultural production. Soil pH affects availability of different plant nutrients in the soil. The level of pH in the soil determines the amount and type of plant nutrients in the soil. So that's one effect. For example, there is low phosphorus available at very low pH. In other words, under acidic conditions, there is less phosphorus. So that means crops that need high phosphorus may not do well in acidic conditions. That's one effect. There's low potassium and iron availability at very high pH. So basic soils or alkaline soils do not favor availability of potassium and iron. That means crops that do well under conditions of presence of potassium and iron will not do well under such conditions where the soil is basic. It affects microbial activities in the soil. When we talk of microbial activities, we are referring to the activities of bacteria, fungus, and others. All right, so we are saying soil pH affects microbial activities. Remember that microbial activities are the ones responsible for formation of manure. So it affects microbial activities in the soil. Remember that microbial activity is responsible for decomposition of organic manure, rather organic matter. OM is organic matter. So if the pH is not suitable for activities of microbial activities of organisms, then there will be less or no organic matter in such a soil. Therefore, crops will not do well. Bacteria tends to be active when the pH is above 5.5, meaning that when the pH is below this, bacteria will not be active and there will be less organic matter in such a soil. Fungus tolerate a wide range of soil pH. Nitrifying and the nitrogen fixation bacteria take place vigorously at a pH of 5.5, meaning at any other pH, the nitrifying and the nitrogen fixation bacteria will not be active that much. Therefore, such a soil would have less nitrogen for crops. Effects of soil pH on agricultural production. We are saying one, it affects availability of different plant nutrients in the soil. It affects microbial activities in the soil. It also determines chemical properties of the soil. So pH determines the chemical properties of the soil. Alright, this decides the type of crops to be grown in the given area. So soil pH will determine the type of crops to be grown in a given area. Some crops do well in acidic soils, for example, tea and pineapples. That's why tea and pineapples do well in places like Churu and Mulanje. The soils there are acidic soils. Some crops like basic conditions, so soils, for example, beans, peas, groundnuts, cabbage, soya beans, sunflower. These do well in basic soils. So we are saying soil pH determines the type of crops to be grown in a given area. Some crops do well under moderate pH, between pH of 6 and 7, not too acidic, not too alkaline soils, just in the middle. Factors that affect soil pH, or rather the effects of soil pH on agricultural production. pH influences soil-borne diseases and soil pests. That's another effect. Low soil pH encourages multiplication of fungi. So a soil that is highly acidic would favor growth of fungus. So soil-borne fungal plant diseases are common in acidic soils. Diseases caused by soil-borne bacteria are also common in alkaline soils. It also is responsible for plant damage by nematodes. Nematodes are soil pests and is more common in acidic soils. So it influences soil-borne diseases and soil pests. Welcome to the second chemical property of soil. Remember that in this lesson we are exploring chemical properties of soil. This is Black Slides Online Secondary School. So far we've looked at a property which is called soil pH. Like I said earlier on, watch this video in chunks of 40 minutes. You watch the first 40 minutes, break for a short while, come back to it and continue another 40 minutes until you finish the whole video. This is an all-encompassing video because it covers all the chemical properties of soil. So welcome to the nutrient status of the soil, which is also called nutrient content. Nutrient content of the soil as another chemical property. Nutrients are basically substances needed by plants and animals for growth and development. So plants need nutrients for them to grow and develop or grow. So availability and amount of nutrients in the soil determines soil fertility. So a fertile soil is one that contains the right type and amount of nutrients. Crops growing in such a soil are going to grow and develop well. So what are the factors that influence nutrient status of the soil or nutrient content of the soil? This again is a highly examinable area. You'll be required in an exam to describe the factors that influence nutrient content for soil. So that's what we'd like to share now. So one of the factors that influence nutrient content or status of the soil is the composition of the soil itself, which is called the parent material. So parent material affects nutrient content of the soil. So nutrient content or status of the soil is affected by the composition of the soil itself or the parent material because it affects the ability of the soil to retain, to keep, and to release plant nutrients. So the material from which a soil is made will affect the ability of the soil to retain or to keep and to release plant nutrients. Inorganic, which are minerals, and organic nutrients. It affects the ability of the soil to retain or to release inorganic and organic constituents into the soil for use by plants, for plants use. Make sure you get this right. So we are saying one of the factors that influence nutrient status of the soil is the composition of the soil itself, or the parent material, the rock from which the soil is made. It affects the ability of the soil formed to retain and release plant nutrients, which can be inorganic minerals and organic constituents. Another factor that determines the nutrient status of a soil is soil structure and texture. Okay? Soils with structures like single-grained, like sand in this case, are prone to leaching. Remember that leaching is the washing away of mineral salts or nutrients by water, rainwater. So soils with structures like single grains are prone to leaching, and this effectively reduces nutrients amounts. So soils with structures like single grains are prone to leaching, thereby reducing nutrient amounts. Another factor that determines the nutrient status of a soil is farming practices or methods of cultivation. All right. For example, bushfires. If you clear land by burning bush, that would destroy the organic matter, which is essential for improving soil structure and releasing nutrients. That's why it's advisable not to burn bush as a way of clearing land. Okay, overgrazing would remove vegetative cover. In the process, the amount of nutrients released into the soil is also reduced. Whereas, so overgrazing removes vegetative cover. In the process, nutrients are then lost through erosion. This point is one. These 2 points are one and the same. They need to be combined. This one is supporting the first one above. Farming methods or practices of cultivation would affect the nutrient status of a soil. So we are saying if you clear land by burning bush, you lose organic matter which would otherwise be part of the soil nutrients. Overgrazing would cause soil erosion, and in the process nutrients are lost. Monocropping, which is growing one type of crop, will exhaust certain elements in the soil. This would lead to the decrease in the nutrients in the soil. Another factor that would affect soil nutrients is soil acidity, which we talked about earlier on. This would affect both the release of nutrients and the microorganisms' activities in the soil. All right? Mineral uptake by plants and crop removal can also affect the nutrient status of the soil. All right, so nutrients are removed when you harvest crops. You remove nutrients from the soil with crops upon harvesting, as they are contained in the plant during growth and development. Okay, so what we are saying is that mineral uptake by plants and crop removal can reduce the nutrients in the soil, especially where you when you're harvesting, you're removing the crops which contain the mineral salts or mineral elements, nutrients. Welcome, learners. Another factor farming practice, sorry. Another factor that would affect nutrient status, the soil is leaching of basic nutrients. Remember, leaching is when mineral elements or nutrients are washed away by water. So this would decrease soluble nutrients like nitrates. As these are washed down the soil profile. Another factor that affects nutrient status is soil erosion. Alright, so when soil is washed away by whatever action, whether by water or wind or any other agents, this will decrease the nutrients as they are washed away together with the topsoil through water and wind. So know all the factors that influence soil nutrient status. Another factor that influences nutrient status is excessive irrigation of land. Heavy irrigation results in nutrients being reached and washed out from the topsoil. So in the process, nutrients are lost. Another one is drainage. When water-logged land is drained to remove surplus water, some nutrients get washed away in the process as well. So for each of the factors, know how it contributes to the nutrient status in the soil. Another factor is use of chemical fertilizers. So increasing or the heavy application of chemical fertilizers will increase the amounts of nutrients in the soil. Welcome, learners. Welcome to the next chemical property of soil, which is called cation exchange capacity, CEC in short. I wouldn't recommend that you should abbreviate cation exchange capacity like this. Okay. When you are writing cation exchange capacity in an exam, make sure you write it in full and not in abbreviated form. Welcome, learners. My name is Mr. Wachilola, your teacher. Let's quickly go to definitions of cation exchange capacity. We shall define cation exchange capacity as the ability of the soil sample to exchange cations at a given pH and per unit weight of the soil. Alright, so it's the ability of the soil either to release or to absorb cations. Remember what cations are. Cations are positively charged ions such as calcium ions, ammonium ions, magnesium ions, sodium ions, and potassium ions, and many others. Cation exchange capacity. So think of cation exchange as involving positively charged ions. It is also the degree to which soils can absorb and exchange nutrients. It is the extent or the degree to which soils can either absorb or release nutrients. Exchanging nutrients, that's called the cation exchange capacity. An example of a cation exchange process can be viewed by considering a situation where you add lime to an acidic soil. Lime added to an acidic soil, the soil that has high concentration of hydrogen ions, calcium ions, and magnesium ions in lime will replace the hydrogen ions, thereby raising the pH. That's an example of cation exchange process. Okay, just an example. So what are the different forms of plant nutrients in the soil? Plant nutrients can be in form of cations, which are positive ions. So these are positively charged ions such as calcium ions, magnesium ions, sodium ions, and potassium ions. Alright, so cations are held or absorbed into soil colloids. Colloids are basically soil particles that are negatively charged. So because these particles are negatively charged, they are able to hold to themselves these positive ions. So cations are held or absorbed into soil colloids, which are soil particles that bear negative charges on their surfaces. Another type of nutrients in the soil is anions. Anions are negatively charged ions such as chloride ions, nitrate ions, and carbonate ions. These are called anions. So anions are found in the soil solutions. These are found in the soil solutions. Right? They are not easily reached from the soil because they are bound to soil colloids. So they can be replaced by or exchanged with anions of the soil solution through cation exchange process, meaning that the place of the anions on a soil sample can be replaced by the positive ions through a process called the cation exchange process. So cation exchange process so we are saying cation exchange capacity. So about that, cation exchange capacity is used as a measure of fertility in nutrients, retention capacity, and the capacity to protect the groundwater from cation contamination. That's one use of cation exchange capacity. It's a measure of fertility, is how fertile a soil is. It's a measure of the ability of a soil to keep nutrients. So cation exchange capacity is highly dependent on the soil texture and organic matter content. The more clay and the organic matter is in the soil, the higher the cation exchange capacity. So clay soil and the soil that has more organic matter carry out cation exchange process better than one which does not have organic matter. Factors that affect cation exchange capacity include type of clay colloids, Remember, clay colloids are soil particles on whose surface there are negative charges. So clay minerals with more negative charges have a higher cation exchange capacity, enabling them to hold and supply more plant nutrients. So the more negative soil sample is, the greater would be the cation exchange capacity, which enables the soil to hold and supply more plant nutrients. Another factor is soil pH. Cation exchange capacity increases with an increase in soil pH. So the more basic soil is, the higher the cation exchange capacity. Another factor is the relative concentration of cations in the soil. Higher cation concentrations would yield high cation exchange capacity. Know all the factors affecting cation exchange capacity. In case the examiner asks you to describe any one of them, you should be able to do so without problems. Effects of cation exchange capacity on crop production. This is an examination area. You'll be required to describe the effects of cation exchange capacity in crop production. So one of the effects is that it influences the supply of some nutrients such as calcium ions, magnesium ions, and potassium ions. A higher cation exchange capacity enables plants to get nutrients for growth and production. Cation exchange capacity competitive rate avails cations to plant roots for uptake. Alright, so as plant roots take up cations, other cations in the soil, water replace them on the colloids. The colloids are the surfaces of the soil particles which are negatively charged. Right, so high concentration of one cation forces other cations of the colloids and take their place. That's called cation exchange capacity competitive rate. Other than that, cation exchange capacity maintains soil fertility. Right, humus, which is organic matter, has the highest cation exchange capacity value because organic matter colloids have large quantities of negative charges. Remember that the cations during the cation exchange capacity process, positive ions, which are cations, are attracted to the organic matter colloids particles, which are negatively charged. Remember, unlike charges attract. So plant nutrients found in organic matter include ammonium, calcium, potassium, and magnesium ions. So these are attracted to the negative charges on the organic matter colloids. Remember all the time that colloids have negative charges on their surfaces in order to attract these nutrients. Note that clay has greater capacity to attract and hold cations. That's why clay is richer in plant nutrients than other types of soils. Sand has no capacity to exchange cations simply because it has no electric charge. In other words, it has no negatively charged colloids. For that reason, sand has low poor nutrient content. It can only be improved by adding organic matter. Welcome learners, this is Black Slides Online Secondary School, your school, where you learn the sciences, namely physics, chemistry, biology, mathematics, and agriculture. It is on this platform that we earnestly and honestly cover the syllabus to prepare our learners for the MSCE examinations. And also note that organic matter contributes to cation exchange faster through the exchange of elements with others that have similar or like charges. For example, some ammonium ions, sodium ions, potassium ions, and magnesium ions. Another factor is soil salinity. Another property of chemical property of soil, the last one in this lesson, is soil salinity. Let's define soil salinity as follows. So soil salinity is simply or refers to a condition that is associated with the accumulation of soluble salts in the soil. In other words, we are just looking at the amount of salt in the soil. It's called the soil salinity. So in the soil you find salts such as nitrates, you find sulfates there, you also find bicarbonates and the chlorides. For example, calcium nitrate, calcium sulfate, magnesium sulfate, sodium carbonate, sodium carbonate, magnesium chlorides, and others. All these are salts found in the soil, including sodium chloride. Types of soils based on soil salinity. In other words, salinity is about saltness of soil, the availability of salts in the soil. Alright, so based on the soil salinity, we have what are called saline soils. Saline soils, which saline means salty. So saline soils, these are the soils which have a high concentration of soluble salts, which can be magnesium sulfates, calcium sulfates, sodium carbonates, and others, magnesium chloride, sodium chloride, others. So the soils which have high concentrations of the salts, soluble salts, are called the saline soils. Soil salinity is caused by a number of agents. One of them is irrigating virgin land with poor quality water. Virgin land is land that has not been cultivated for a long time. So irrigating such a soil with poor quality of water would lead to accumulation of soil salts in the soil. As water evaporates, the salts build up in the soil, that's supporting the same point above there. Another cause of soil salinity is application of chemical fertilizers. This may lead to buildup of salts in the soil. If you apply heavily, you rely on chemical fertilizers, the soil will become salty. Salts contained in parent material is another cause for salinity. Upon weathering, salts are released into the soil. Another one is poor drainage. Salts tend to build up in poorly drained soils. Alright, so poorly drained soils have more salts in the soil. All these are factors that lead to soil salinity. On the basis of soil salinity, some soils can be considered to be sodic from the word soda. Sodic means having to do with soda, and in particular having to do with sodium. So sodic soils are those soils which contain high amount of sodium in form of sodium chloride. So if a soil is high in sodium chloride, such a soil is considered to be sodic. a soil sample can also be considered to be sodic saline soils, meaning that both sodium and the salts combined were found in such a soil. Right, so these are soils which contain both soluble and sodium salts. Right, note that high amounts of sodium in sodic saline sodic soils are toxic to plants. In other words, they kill plants through loss of water. They cause plants to lose water by osmosis. Remember that in osmosis, during osmosis, water moves from the plant tissue or cells to a region of high solute concentration that will cause the plants to die. Alright, so based on soil salinity, we have three types of soils, namely saline soils, sodic, and sodic saline soils. How do you manage the saltiness of soils? Right? We can manage saline soils by irrigating soil by flooding with salt-free water. So by simply flooding the soil with salt-free water, that can reduce the amount of salts in the soil. So salts are flushed out and become leached by the water. So one way is irrigation. Another one is the drainage, right? When you drain water from the soil to carry away the salts in the soil, making the soil less saline or less salty. Another one is by applying gypsum, which is calcium hydroxide, rather calcium carbonate. All right, this helps to convert insoluble carbonate salts into sulfates. Okay, so readily soluble and easily leaching through irrigation. So apply gypsum. It is going to convert insoluble carbonate salts into sulfates. We can also reduce or manage saline soils by preventing or reducing evaporation. Alright, this minimizes the buildup of salts in the soil. Remember that when you evaporate the water from the salt solution, the salt crystals will build up in the soil. Also growing salt tolerant crops that can do well in salty soils. This can successfully survive in saline soils. Make sure you know all these, 5 of them, for an essay question in your agriculture exam. Effects of salt accumulation on crop production. This is an exam question. It increases soil pH, meaning it makes the soil more alkaline. If the soil has too much salts in it, it is going to become more alkaline, making some nutrients unavailable to plants. Example: potassium, iron, manganese, boron, magnesium, and calcium. These are unavailable in a soil that has high pH. So we are saying one of the effects of soil accumulation on crop production is increased soil pH, making the soil more alkaline. It also influences water availability due to osmotic concentration. So this affects seed germination and plants growth. So there's an influence on water availability. Remember that water moves from the region of high water concentration, water moves from the region of low concentration, solid concentration, to the region of high solid concentration by osmosis. So this would lead to water loss, which is going to affect seed germination and the plant's growth. Salts may also be toxic to some crops, especially those that are sensitive to high concentration of salts. So these are the effects of salt accumulation on crop production, not all of them, so that you should be able to give Na2 when required. How can you determine if a soil is saline or salty? So you'll be required to describe this in an exam. Describe an experiment that could be done to test a soil sample for salinity. So you collect a soil sample, about 20 to 50 grams, and let it to dry for a day or two. Then crush the air-dried sample with a hammer or use a mortar and pestle. Alright, so you crush the soil. This crush, I beg your pardon, should be CRU, not CRA. So put the soil sample into a jar with a lid and add distilled or rainwater to it. 1 part of soil for every 1 part of the water. 5 parts. That's like 20%. Alright, then shake the jar vigorously for 3 minutes to make sure the salts dissolve for 3 minutes. And then let the soil solution settle for at least 1 minute before testing. Once that is done, place the salinity meter electrodes in the solution. This is a special tool for testing the saltness of water. So place the salinity meter electrodes in the solution, but not in the soil at the bottom of the jar, and read the display once it has stabilized. Wash the meter electrodes and the sample jar with distilled or rainwater and dry them. Just make sure that they are right after use. Then convert the salinity meter readings to soil salinity by multiplying the value by the conversion factor. Okay, the conversion factor is basically a multiplying factor which comes from each type of soil texture. Different soil textures have different conversion factors. So it depends on the soil sample that you're dealing with. So take the meter reading multiplied by the conversion factor, which in most cases has to be given. You have to know. And then multiply, that will give you the soil salinity. Welcome, learners. So this has been your teacher on this platform. I must confess I enjoyed presenting this